Okay, so our square method is pretty useful. It saves us some time. It basically saves us writing out 8 commands every time we want to write a square. But it only does a square of a fixed width, which is 100 pixels. So it's sort of natural for us to try to develop another version of square, which was also going to be similar to the way the library works. So let's create a version of square now that takes a parameter for how long the sides are going to be. Draws a square of the given length for the sides. Okay. Alright, and just to save time, I can copy all of this code from the original square. Come on down here, paste it in, add the integer, which is going to be the length of the side, and I'm going to call that side len, and make it camel case like I should. And then all I have to do down here is add side len into the forward, Control save. And now let's write an interesting program here that draws different size squares. So I'll come back to my turtle method file, and let's go ahead and throw a for loop in here. So for int squares equals 0 while squares is less than let's just do 20 squares this first time. Squares plus plus. Alright, and then I'll create a loop. And notice I'm going to just save some time here. So I already have this program set up to draw one square. Now I'm just putting a loop around it. But what I want to do here is use a parameter. And so, whoops, looks like I have a typo here. I missed. Fix that. There we go. Alright, so basically I could go ahead and use squares here, but that'd be kind of bizarre because I'd have a 0 to 20. That's not going to be very big. So why don't we create a little on-the-fly formula here. So we'll say squares plus 1 and I'll put that in parentheses because of order of operations, times, and then I can figure out a multiplier here. So let's just look at our endpoints. If I do 5, then the largest square will be 100, which is what I have currently, and the smallest will be 5. Actually, that'll be 105. I forgot. Let's see. No, that's right. 19. Okay. Let's try 10 here and see how that works. I think that's going to work pretty good. So just to see what's going on here, I added the 1 in so that the first time I had some value here other than 0. So 0 plus 1 is 1 times 10. So the first square will be 10. And then it'll roll through 19 plus 1 is 20. So that'll be 200. So I know that'll fit on the screen. And let's see what we get here. So we'll go ahead and run this. And that's a pretty nice little pattern I got there. So I'll go ahead and stop this. Now let's try a little experiment here. First off, we'll add some color in here. So let's go ahead and get our random in. So random RND equals new random. I think there's a shortcut here for inserting. Let's see, Control Shift I. Did that do it? Yep, sure did. So Control Shift I will add the import in for me. Alright, good. I think that's the same in Eclipse, by the way. Okay, so I want to create a random color now. That needs to be in the for loop if I want the color to change each time. So, and notice I don't really need a color variable here, so I'm going to do this and kind of write it in a functional style. So tom.set pen color, and then this is going to be new color, and then R&D dot next int, and then let's see, why didn't I get the parameter in there? Okay, now this is not going to be squares. It has to be 256, right? Okay, so here's what I need to copy. Control copy. Seems like I've got an extra paren in there, but I'll deal with that here at the end. Okay, so let's see what that matches. The color, yeah, oh, we're good actually. So the only issue is we have to insert the color. Let's see if it works again. So Control Shift I. Sure did. AWT color. Coolness. Okay, so I'm setting the color to a random color before I draw each of the squares. And let's go ahead now and just add something else in here. I'm going to turn the turtle a few degrees each time. So tom.turn, and let's I'll start by just making this a this is degrees, so I'll say 10, and then we'll try that. Obviously I could turn the turtle a different amount each time too. So now you can see I'm getting the color and as it goes around. Now if I wanted to go further around, I need more squares, so let's make this 30, and oops, I forgot to stop it. Run it again. There we go. And that's actually kind of like a spiral, although I'm not exactly sure that it's Archimedean. We have to get the right size to get an Archimedean spiral. But that's kind of nice. Alright. Now, let's play with this a little bit. I'm going to go ahead and adjust this turn amount so that it increases. And basically I'm going to just take squares plus 1 for that. Let's see, oh, that won't be enough. How many want? Let's see, I'm doing 30 squares. So let's see, 360 divided by 30, that's about 12. Let's say, yeah, let's just try that here. So I guess I'll turn it the same amount, but I'll each time still, but I'll try and see if I can get it to do a circle. I'm just playing around now, but that's kind of the point with the media computing, is you can try different parameters to get different effects. So notice the spiral now has a little bit different shape because of the turning between the squares that form it. That's kind of cool. Alright, now just for shits and grins, I'll try one where I turn a different amount each time. I'm kind of curious what that'll look like. Okay. So right now, I'm turning a constant of 12 degrees each time. I want to create something that changes in here for each loop. If I use the squares, that's probably going to work okay. So let's try that. And I'm not sure if it'll work if I tell it to turn 0 degrees, so I'll just say squares plus 1 to avoid the 0. Alright, let's see what we get. It's kind of interesting. So now it actually spins out because it's turning more as you get further along here. So you can see this is real tight, and then it starts to expand out. Alrighty. Well, I think that's good for our next video. So